Do, 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 do. I need a little jingle to add here, I think. Yes, that would be interesting. If anybody has any suggestions for jingles I can add to the start of the broadcast, please let me know. Hello, and welcome to Practically. My name is John Stevenson. Thank you very much for joining me. I think we're starting a little bit early, but it's all recorded so people can catch up. Okay. Well, today we're going to do something interesting. We're going to do some data science. And in a more serious note, we're going to look at some of the COVID data as well. So obviously there's a pandemic on at the moment, and it is quite a serious situation. And hopefully looking at the data will give you at least a chance that you feel like you're learning a little bit more about what's actually going on. Data is open to interpretation, so there's no like solid answers that we're gathering here. We're just really trying to explore the data and get a feel for understanding how to manipulate data and kind of some of the fundamentals of managing the data for data science. Caveat is I'm not a data scientist, so I'm not going to try and make any claims on this data. I'll leave that up for the professionals. Okie dokie. Oops, where's the right button? There we go. Okay, so we're going to have a look at this baby steps in a moment. But if you want to reach out to me or see any of the other videos that I've done, then they're all on the Practicalli website, so practicalli.github.io. And I've got this is a 64th study group screencast we've done. And there's also some videos on Spacemacs and some other tooling as well. If you want to reach out to me, then you can do that via the Clojure and Slack community. I've got a Practicalli channel. I should really do a Zulip one at some point as well. And there's also lots of help you can get on the Clojure and Slack community itself. And if you want to support me, motivate me, then subscribe to my YouTube. This is an easy one to do. And also, if you want to financially support me, there's a couple of channels there. You can use that as well. Any support is much appreciated, and I really thank the people who've supported me so far. Okay. And just before we start, I just want to mention that there's a hackathon today and next Sunday around data science. So if you want to practice some data science, like building on what we've done today, then joining in this hackathon either today or next Sunday will be great. Opportunity to do so. You don't need to have any data science background. If you know a little bit of Clojure, that's helpful. And the details are on the website. If you just go to scicloj.github.io, you'll be able to find the details there. Okay, so we're going to go through this article, which is really good. There's a few extra bits I've changed in this, and just tweaked it around, and I'm going to explain a few bits that aren't covered in this article as well. And if you've got any questions as we go along, please feel free to put them in the chat, and I'll try my best to answer them. I also have the code in, which I put in the, if you look in the chat for this broadcast, there is the data science COVID. I need to change that now. Yeah, I spelled COVID wrong. COVID wrong. So there's this repository I've created already, and it's got the, if we go into the source, there's a design journal, which has got the code for the walkthrough that we're going through this morning as well. So if you want to copy that, and you can evaluate along. And there's also the in the link in the code here, there's a link to the data as well. If you want to get that locally, then you can just go to the website and just click on Save Page As and save that to the resources directory of the project, and then you can use that locally as well. We'll do both approaches, so you are covered. Okay, let's get started. So I've got the project open in my editor. I'm just going to start up a REPL, just a normal Clojure REPL. So this project uses Clojure CLI and deps.edn files, so you will need to have the Clojure CLI tool installed. But apart from that, it should just work. Okay, and so there's the article talks about data. So we're using the Johns Hopkins data set. So first of all, we're going off and grab that data set. So there's links here to the actual data it's using, which I think is this one. So the article gives two links because it's there's the official Johns Hopkins University repository, but somebody's also created a copy of this because Johns Hopkins ones is kind of been updated a lot more and changing a bit more. So there's this open COVID-19 data which is aimed at developers and is not changing as often. It's not going down at all. I think sometimes there might be some batch jobs running in the Johns Hopkins one, so it's not quite guaranteed to be there. But if you're copying the files down locally, then it shouldn't be a problem anyway. So I think these files are all the same, and it's really the output of these. There's some comma separated value files for specific countries and for the world itself. So we're mainly going to work with the world in this broadcast. That's what the article mainly works with as well. And we're just going to start grabbing the data. So let's see how we do that. So we can just get the data directly using slurp. Slurp is a very simple function that's part of Clojure core. You can just go off and grab the data. So I've got a def here that just defines the URL of the data, and then we can just slurp it in, and this will go back and pull down. It pulls down all the data as a string. It's not the most ideal format for a piece of data, but it's a simple way to get the data in the first place. And so if you've just got some random data on a website, then you can just slurp that data in, and off you go. If you are going to hit a website, then it is polite to cache the data. So what you could do is have a def that is your data cache and slurp that data in. And so once this is called, so we can evaluate it, and once we actually call that data, then it's going to go off and slurp that data. And once it's done that, every time we use every time we evaluate data cache, it's going to use the results it got the first time. So it's not going to hit the website over and over again. So that's a useful technique to include, because otherwise, if you do start hammering a website, then they start to put up notices saying "Do not scrape this website," or if everybody did it, it would be another form of denial of service attack. Ooh, excuse me, that was my stomach. Okay, so it's very easy to get the data sets, but one thing is if you are going to cache it, then you want to make sure it actually fits in memory. Otherwise, it's not a very good approach. If it's got a huge amount of data, then if you try and put all that in memory, you'll need a very big machine. So another approach is to use the Clojure Java I/O, so input-output API. And so we can just require that into our namespace, and I've done that at the top as well. So here I've put this into the require statement, and I'm just putting it as an alias of I/O, so I can just refer to all the functions inside that library, just with prefixing them I/O. And so then there's a reader function in that namespace, in that library, and we can use that to get a buffered reader. So that's much better for large files, and if you want to stream data in as well. But at the end of the day, that gives us an object we can use, and we can just slurp data from that object again. So we get the same results as we would do from just slurping the file. It just adds a little bit of extra robustness to the code, and so it's quite useful. There's also like a with open. If you're going to do this as a production application, you can also wrap this in a with open function that will make sure the file is closed when you actually are finished with it. And so for the rest of this broadcast, I've actually just saved the file locally. So I just went onto the website here and saved the file locally. So just go on there and just save this page as into the resources. And if you're using the reader, wrong button. There we go. If you're using the IO reader data, then you just give it the full path from the root of the project, and it will find the data file for you. So I've just got a def local data here, and I don't need to worry about caching it. It's all just local as well. If you're hitting a slow website, then that's useful to use as well, because obviously it speeds up your development if you don't have to wait for the website to respond. I think in the original article they're using resource instead of reader, and this will pull out files from the path that is relative to the resources folder. So if you're doing a web application, then you might want to use IO resources, IO resource function instead of reader. And you can see this pulls out an object, but it also gives the full path of this. So if that's in a web application, then it would find the correct path relative to the web application that you're building. And there's some of the links here that if you want to work with files and directories in Clojure, there's some good tips and tricks in there as well. Okay, so it's very simple to get the data, but at the moment the data is just one big string, which is, although you can do a lot of string manipulation in Clojure, it's better to actually put it into Clojure data structures. And then we can really do some really nice transformations of the data very, very simply. And a lot of data science, actually a lot of the things you're doing in any software programming in Clojure is taking a data structure and transforming it into a different data structure through algorithms, or to actually just make your code simpler to be able to process it in a simpler way. You could say, some people have said that the web is basically just a function. You pull data in, you do something to it, and you get a result. That's essentially what we're doing. We have different functions to do different things with the data. So the original data is in CSV format, as we've seen, and so we can use the Clojure CSV, Clojure data CSV library to basically convert that from CSV into a nice simple Clojure data structure, and then we can use all the Clojure core functions to manipulate that and get it in the shape that we want to work with. And so if we want to use that, we do need to add a dependency to for the library. It's not part of the Clojure core library. So if we have a look at my dependencies, so the dependencies are just in the deps file. And so this is just the deps.edn file, which is like the Clojure tools deps approach to configuring a project in Clojure. And so we've got Clojure in there as a dependency, but we've also got this Clojure or Clojure data.csv as a dependency of version 1. And I've also added the this ASCII data library. This is actually a Java library, but it's just a dependency. It's just a Maven jar file, just like this is. So we can just include that in the dependencies as well. And everything else is just kind of out the box generated by the template that I used to create the project. I put tests in the path just in case I wanted to run tests from within Cider, within Emacs, but normally you wouldn't include tests there. Okay, so we can require it here. I've also got this at the top of the file as well inside the namespace definition, but just for convenience, so we require this, and then we can start evaluating we can start converting the thing that we get back from Slurp. So the string we get back from Slurp, we can just convert that into a Clojure data structure. So we actually get, now instead of a string, we're getting a sequence of vectors. And yeah, you can see that, so we've got a sequence, so we start with the list, which is our start of a sequence. Inside that, we've got a vector, which is the headings of the data. And then after that, there's individual observations. I think I've got some examples here later on. Where is it? Yeah, here we go. So this is what we're getting out of the data. So we've got a list, because we're returning a single value from the function, and that value is a sequence of all these different vectors. So square brackets is a vector, like an array in Clojure. And each vector has the dates, the country code, the country name, the confirmed number of cases, number of deaths, latitude and longitude of that country as well. So this data is so much easier to work with than just a single string. And so now we can experiment and explore that data and try and understand it. One thing that was mentioned in the article was just create this little helper function, because there are multiple multiple CSV files. So there's one for world, China, USA, and a few other countries as well. So you can just narrow it down to working with specific countries if you want to. In this case, we're just going to use COVID world. So this helper function basically is just wrapping this read CVS, that's a read CSV function that we used, and we're just using format to basically construct the names of the file names. So we would copy the file names locally for world, which we've already done, copy China and USA down, and this format function is basically just replacing here, substituting in here the particular location that we're passing in. So if we pass in world, then we get resources world. So it's just a little way to construct a file name on the fly with just a piece of information we get from the function's parameter we pass. So we're just going to work with COVID world. So we're pulling that in, and then I could just use COVID world as a reference to the data. So this is what we're doing here. So we do first. So this is all just a big long list. So we can just use our sequence functions. So like first, second, rest, last, all those things that are really handy to work with sequences of data. And we're using this to just break down, see what kind of specific data we've got. So we've got COVID world. So the first one is the heading, which is useful. That tells us what each of the individual strings are in a particular vector. And so second is just grabbing the first observation. And so here we can see, so this is on a particular date in a particular country, there was this amount of confirmed, this amount of deaths, and this is the longitude and latitude of the country, or I'm not quite sure what the specifics of the longitude and latitude are in this case. I don't think we're actually going to use them, so that's something to have a look at afterwards. And then if I wanted to know how many there were, how many observations have been taken, this is something I've slightly diverged from the original article. So instead of just counting COVID world, that would count the headings as well. So that would always give you one extra. So to be more specific, then I'm grabbing the rest of COVID world, which is everything but the heading. So we skip this first part of the data structure. So we ignore this because this is the first, and the rest will give us everything else. And there's quite a lot. So this is truncated. There's a lot more data in there than just I'm showing here. And then, so that gives us a count of 5,609. That was yesterday. Let's see if it's. I did update it. Oops. Oh, I think I've. Did I not evaluate all these? Oops. Remember to evaluate these as I'm going along. Oops. I forgot. There we go. Let's evaluate that. There we go. Boop. Okay, so this should work now. So yeah, there we go. There we go. And so the count is. I did update the file. So so the count. We've added another 160 odd observations since yesterday. So that's useful. So the number of countries has gone up as we've done that. So there's at least a day or 2 days worth of extra observations. So a comment saying latitude and longitude are usually the center of the country. That actually makes sense. Thank you very much, Mark. Okay, and so we've got, so we know how many observations have been made worldwide. Then we can also look at see how many observations have been made for a particular country. So we can use distinct here, and we're going to map over this function. We're going to take the second element in each of the observations. So we've got the second element is the country code, and so we're going to get that and see how many of those are distinct using the rest of the COVID data. So we're going to, again, we're not going to include the headings in that. So we see that gives us a list of all the, so unique list of all the countries that we're dealing with, and that's across the whole set of data. So like the whole range of dates. As we'll see later on, not every country was recording data at the start, so it starts off smaller and then it gets bigger. And so there's also a different way I thought of doing it might be a bit more efficient. Again, this data is quite small, so relatively speaking, so you might need to do a little bit more of efficiencies if you've got a really large piece of data. So that's just a simplified way of expressing it. But so all these three are just the same, just a different way of actually finding out the list of countries that we've got. And then we can go find out how many countries are actually involved just by counting. Oh, we've got 164 now. That's interesting. That's a lot of extra countries just added in the last couple of days. That in itself is interesting. So there's a lot more countries reporting. Although this, you'd still need to qualify to see whether, like, some countries might have had their names changed. I think the South Korea changed. Some reporting around South Korea was changed. The name was changed to the Republic of South Korea or something like that. So you would need to go through the list and see if there was anything that was different to your expectations, or you'd have some kind of, if you had some kind of lookup of all the official names of countries, you could then compare to see whether anything was different to that. Again, we have no guarantee on the quality of any data that we ever use. Obviously, if you're using a respected source like Johns Hopkins, then if you've got a lot more confidence you can put into that data. But yeah, no data is kind of foolproof. So it's worth inspecting it as we're doing now. Yeah, so as I mentioned, like, one of the biggest challenges to kind of get good data and understand the quality. So we can kind of explore around here and see if to see whether so the count of the COVID world, see if we've got reporting really for all of the countries all of the time. So it's getting better. Oh yeah. Yeah, so it's getting better. There's less, so more and more countries are reporting. So we're taking the the count of the whole data set, and then we're seeing how many countries are remaining, see what's remaining between, dividing that by how many countries there are. So if there was 0 remainder, then all the countries would be reported for all the dates, but that's not quite the case. But it is getting a lot better. As you see, it was a couple of days ago, it was like 137. Now it's a lot closer. It's down to 30. So there's more reporting going on across the world. So that's a good thing. At least we've got more information that we can work with. So we can also find out how many data points are missing. There's a bit more that, we've had another set. So this is how many data points we've got. And this is how many dates we've got. So we've got 82. So this is we've got an extra set of dates since I did this yesterday. And so we've got 13,000 missing observations. I think these are mostly from the start. So we should have 13,000 observations, but we've got just under 6,000. So we've got about half of them missing, and most of those because we had a much smaller set of countries when we first started. So we can see that by looking at the data and seeing how many of those countries have like 0 data. So we already know how to get the first thing out there, and somebody mentioned in the comments you can also generate this data in a map, so we can actually use maps to kind of do this. But for the example we're doing, we're just keeping it simple and just using a vector. So we're going to map the third value over the rest of covered world. So here we've got third. So when we're mapping the nth of third, we want to get the third element, and that's 3 represents the index of the vector. So a vector is like an array, it has an index, and like most arrays in most languages, it starts with 0. So date is 0, country code is 1, country name is 2, and so confirmed is 3. So we're actually pulling out just the confirmed cases. So we're pulling out, so most of those are 0. There's a few that are reporting things, so that could be China, because that we're reporting quite early on in the process. And so because we can get the 0s, then we can actually just filter those out. Although it doesn't quite work because the data is not in the format that we actually want it to be in. So we're getting a cast exception because we're trying to use a string here. We're trying to use a string as a number because we've got this 0 predicate saying it's like trying to compare something as a 0, and if it's not, it's actually as a string format, as we saw here. You can see these are all strings, so we need to convert those into the right format. We could write our own little function here. So I've written a little inline anonymous function, which is just comparing 0 with the value, so to see if the value is a string of 0. But we can also convert the data, which is much better actually, because we're always going to end up doing this if we're working with numbers, and also we'd have to compare every single value in every as a string, which wouldn't be very efficient. So we can convert the data, and there are some other libraries that will help you convert data as you're generating it as well. So the Clojure.data.csv is just mainly to take the data as it is and put it into a Clojure data structure. but there's something called semantic CSV, which I think I've linked to later on, which will convert the values into particular types of numbers as well. So we could do some manual conversion here, and we're just getting all the elements out of each observation, out of each vector, and we're going to return them as they are, except for the confirmed and the def values. So we're just converting them into well, an integer, a long integer in this case. Again, there are a few different ways to do that in Clojure. And so now we've got our COVID data is now converted, so we can oops, oh, is that not working? Oh, so now so we can see that the numbers are actually numbers now rather than numbers in strings. So that's going to make it easier to work with. I'm just putting that inside a def to allow us to refer to that. So I'll just call it COVID world data converted. So now when we can run that, it's much simpler. We can just use this simple filter function with the predicate 0 and over the index of 3 value from the COVID world converted information. And so that gives us, we can get a count of how many of those observations, which is quite a lot actually. There's considering we had like nearly 6,000 observations, there's like half of them are reporting 0, which kind of seems a little bit strange, and so you kind of have to wonder how good the quality of the reporting is initially. I guess people were still ramping up to try and report that, and also the amount of testing that was done in a country as well. So if there isn't any testing being done, then you're not going to be reporting any confirmed cases. And so so I think there was a period where the reporting data possibly isn't as accurate as it could have been. And so if we wanted to convert, we could use semantic CSV to convert information into specific types as well, and so that's quite a nice thing. It generates maps for you, maps of data rather than just simple vectors. Which can be more useful in the long term, especially if you want to do a lot of manipulation with the data. Here we're just doing very simple stuff, so vectors are perfectly fine for this. So we can delve into this a little bit more, and we are having a look at sort of date frequencies, so how many observations are happening on each day. So we've got here a little def, so we're going to map so we're going to get the first element from each observation in our converted world. It doesn't actually matter if we use the converted one or not, because we're just looking at the date of the observation. So just the first element of each vector. So that's what map is doing. And then we're using frequencies to see how often that date is occurring. So that way we know how many countries have reported an observation on, or how many times an observation has been reported on each date. And then we're just sorting by first, so we can put them in some order. And then what I'm doing is I'm going to look at the results of that, because this is just a def. We're just defining this date frequencies to hold that information, and then we can go and explore it. There's going to be quite a lot still. It's going to be like several hundred rows of data. So we're just going to use take 10 just to get the basics of just the first sample of that data, to see what we actually have. And so we're getting back a sequence of vectors, and each vector has the dates and how many observations were made on that date. So you can see the dates started at the end of 2019, and there were probably 66 countries or 66 observations that were made for each of those. For each of those dates as we go along, and I think we can probably check to see that those are all probably 0 recordings. Pretty much we saw earlier on that just about all of those were 0 recordings to start with. And we can actually just do a simple drop and take to walk through the data set as well. So we can use code to walk through bits of data very, very simply. So here we're going to drop the first 10. So we've just seen the first 10 results from date frequencies. We can drop the first 10 from that, and we can see the next 10. So we can kind of have like a sliding window just by evaluating this and changing the numbers. And you can see that up until like the first 2 months, then it pretty much was just 66 countries. And then something strange happened around about the start of March, when there was a drop of countries actually reporting. And then it started building back up again. And by around the 11th of March, then all the countries, like more and more countries, started reporting the thing that was happening. So it's quite interesting. So like looking at what was actually happening on the 11th of March or around the 11th of March is something useful to do. That might help understand why there's change in that frequencies as well. And sure enough, if you actually go and look at the great internet in the sky, the March 11th was when the 2020 pandemic was actually announced by the World Health Organization. So that's when a lot of countries actually started taking reporting more seriously and started doing it more often. And this is when we start getting more details, more information, more data from across the world. And we could also, if rather than kind of manually walk through this as well, we could also do something like drop while. So while it's just because the first 2 months were just 66 countries pretty much exclusively. So while the value was like less than 66, then we can just drop those. So if we look at here, so our values are the dates and the amount of observations. So if we look at the second one, the second value in each of these vectors, then we can compare it to see if it's 66 and just drop them. And so then that would kind of show us from the 3rd of March, I think, if there aren't any others. Yeah, so this is what this is doing. So this gives us that starting point where there's a change in the number of countries reporting. And so we could also do this where it's above a certain number as well, where it's like greater than 66. And then it would show us like probably it would show us the 11th of March. And then we could see, that's when more countries started to actually do observations. And then we'd know. So it kind of helps us hunt down kind of significant changes in the data gathering process. So that's quite nice. How are we doing? 37. Any more questions? No. Okay. So we're doing good, and I think a lot of I'm no expert, but it does seem that a lot of the work done as a developer in data science is just kind of getting the data and organizing it into ways that somebody can actually make some meaningful senses out of it, and then presenting it in different ways so you can actually gather information out of it, and then also presenting that into some nice visualization tools as well. So we've looked at the reporting frequencies. So we can actually look to see how much data that we've got from a particular country. And so we're kind of doing the same thing here, except we're now looking at the country codes. So that this map second is looking at the country code, and so we can see how often the particular countries are actually reporting. And so you can see that there's a big difference between how often countries are reporting. So it's not consistent. It's not uniform, unfortunately. And we can also look at a specific set of countries as well. So we can have selective countries that we look at. Here we've just created a set. So these are the set of countries that we're kind of interested in. And we can filter out for those particular countries. So we can just narrow down the world. So if there wasn't separate files for China and so on, we could actually just narrow it down by looking at the specific data, just by filtering out that information. And so when you filter something, you just return everything that matches the condition that you're applying to that data set. So here we're looking at, we're pulling out the value of the code from our selective countries, and then just pulling out from here, just filtering everything that matches that one of those countries from the data set. We can just take 10 of those, and we can see that. Oops, there we go. So we've got China, Spain, France, and Italy. So if there was a group of countries that we wanted to focus in on, then that would help us narrow in. Because obviously, if you're looking at the world, then that's a lot of data to look at. Okay. And we just wrote some helper functions just to kind of start tying these together. So these are the functions I'd probably put into the source code. Again, I've just done this as a design journal, just as an experiment to figure out what it is that I actually want to build as a final software project. So we could put these help functions into the actual source code and put some unit tests and maybe even some generative tests around there as well, and start building up a software project around this data. So just really codifying what we've done already, so we can take the countries and get the date frequencies, country frequencies, and we can define the countries I'm interested in as well. And so then we could just tie that together and just get the particular information we want from the countries that we want. And so this helps us see, so you can see that these are countries that have been fairly uniform in reporting it, apart from Serbia, which is not, which probably started a bit later. Okay, so that's given us a chance to explore the data. Now we think we know enough to be able to try and visualize some of that data. And there are some great visualization tools. We'll have a look at the Oz just before we come to the end of this broadcast. There's a nice project there, but you don't have to do full on fancy graphics. There's also a very nice this ASCII graph, which is quick to use, and it gives you enough of a visualization to be able to get some basic meaning out of it. So it's quite a nice little tool, especially as you're developing the application, to be able to see if your visualizations are getting close to what you want it to. So it helps keep that speed of development going. And so here we've just got, we're going to take a, this is from the original article, they take the Serbian data. I believe the author is based originally from Serbia. So what we're doing here is we're going to use these helper functions. We're going to take the countries, in this case specifically Serbia, from this, and we're going to get the third element, so the number of confirmed cases, and then we're going to drop all the ones that are 0. So this just gives us all the non-zero confirmed cases from well, it's ignoring all the cases it's ignoring all the observations that were made before the first confirmed case, and then then we're getting back all of those observations so once we've got the first confirmed case, it's going to return everything after that as well. And so we can then use this ASCII graph library to plot something. So it's got a from series. So we've got a series of data that we've just generated from this Serbia data. The ASCII graph library wants to put this into a double array, and then we just plot it. So this is just calling the dot plot method. And it's we're using the dot because we're this is a Java function. This is a Java library that we're using. And to get the results, we're going to print them out, and that will appear in the REPL buffer. If you're using an editor, if you're using the REPL already, then obviously it's just going to appear as normal. So if I evaluate this, and so it's print line, so we're going to get nil as the result in the editor. But if I switch to the REPL window, so this is my REPL buffer in Spacemacs, then you can see that it's actually printed out this chart, and it's done quite a nice job. So you can kind of see very quickly, and obviously I can make this full screen if I wanted to as well. But you can see that if we look at the article itself, it kind of shows you what it looks like. Oops, where we go? There we go. Whee. Oops. Where is it? Yeah. So this is what we're getting back, but it's kind of exponentially. It's kind of reporting on top of each other, so it's not kind of giving the growth of that data. So it's not quite how we want to present that information. But this is a very quick way to see whether we've got the information, we're plotting the information correctly. So what they did was just define this simple logarithm helper function, and then we can just map that function over the data, and this gives us a better view of that data when we plot it. So if we look at that in the and here, so now we're getting the kind of the growth over time, and I guess it does depend on your font how well the ASCII text displays, but you can still see that it's kind of it looks more useful, a kind of graph to show how the confirmed cases are kind of growing, and whether so it's quite a steep grow to start with, and it starts kind of tailing off over time. So that gives us also a bit of confidence that we are actually managing the situation. And then so this is just creating. So this is missing from the article, but I've just created a log plot which just wraps this plot function up here. Oops. Which just wraps this plot function in here into a shared function that we can call, and just substituted like the series data in here, so we can call it with any data that we come up with, and also then created this confirmed cases. So we actually just calling this with a data source and a country code. Then we can get the confirmed cases from any country. So I'm just oops, I pressed the wrong button. Evaluate that, and now we can just get the data from Italy. As I've done it reverse, so we can kind of see the big numbers up front. And so we can get just like series data just by calling confirmed cases. So this is probably another function I'd put into my kind of completed application. And I can plot that. Well, I can't plot that. Oh, what have I done? Did I change something? Oh, did I not evaluate log plots? Maybe I didn't do that. I didn't do that. There we go. Oops. It does help if you evaluate. There we go. It helps if you evaluate your functions. So we can see, yeah, so here we can see that we can see the progression of the confirmed cases over time. This is how many cases have been reported. So we can kind of see that that's the Italy. So there was nothing reported, and then there was a fairly steep increase initially, and then it starts to tailor off there as well. There we're doing. Got 10 minutes left. Okay, that should be enough. Yep. Yeah. I can do the same thing for China as well. So it's we're just log plotting that. And you can see this slightly different. So that's really flattened off now, according to this data. So there was an initial bump, and then quite a rapid climb, and then it started to tail off now around about. So it's tailing off around about the same time as Italy. So we get like 10% of that. So it is. We can take some small confidence that things are being kind of managed. And what else did I do? Oh yeah, and this is showing kind of the range of the data as well. So here we're using a slightly different plot function. So we're actually creating an absolute series slightly differently. So we're going to create kind of range of things. So I'm going to show you that in the plot so you can see what it's doing. Did that work? Yeah, so it looks the same to start with, and then we actually see it's kind of showing you the kind of range of the plots as well. So you can still do quite a bit of interesting visualization, even though you're just using ASCII text as well. I think the web page probably shows this a little bit better. Yeah, there we go. So you can see how things are fluctuating, and so the range of cases, confirmed cases as well. Okay, so that's the baby steps article kind of covered, and there aren't any other questions. Oops. Let's see. Maximize. So I think that's. Oh, was there anything else? Yeah, that's all the code I've got, which again is all on GitHub. Before, just to wrap things up, to kind of show you what is possible in terms of the visualization of code, because obviously you may not want to just deliver ASCII code plots, especially to like a business team. So there is a project called Oz, which is here. Here we go. So I saw this from the Clojure universe. Where are we? Beep. And here. Where is the page? Is that the page? Yeah, there we go. So on Clojure Universe, there's somebody, Dave Lakeman, who's actually taking part in the Cyclo hackathon this afternoon. Shared this COVID data in the REPL. The main difference is, so using the same Johns Hopkins data, except he's using Viz, Oz library to be able to visualize these. The data in a much more kind of interesting way, and lots of different visualizations. So I'm going to briefly look at that just to show you how to use that application. So basically just go in and where is it? Yeah, so go into the repo and just clone that. Clone repo, and then just open the Applied Science COVID CLJ viz file, and this is like the Oz library, so the Oz source code you'll need. So we go into my editor. So I've opened this. Have I done this? That's not the right one. Where is it? No, there it is. So this is 400 lines of code. So I'm not going to go through all of this, but I'm going to show you how to actually use it. So it's including a whole bunch of stuff, specifically Oz core as well. So that'll do the visualizations. So we're doing. So this is basically got an Oz server. I'm going to start a REPL in here. Just starting a normal Clojure REPL, and it's that was quick. And then I'm just going to evaluate the whole buffer. Boom. So it's going to evaluate the whole code. So this will likely load up everything. So it might take a few moments. But you've got all these Oz views. So this is actually creating a view. So let's create a web page that you can actually display. So if my browser is doing this as well. And so there's a few different visualizations. Because I evaluated the whole buffer, it's gone and evaluated all of them. So it's shown them in kind of a sequence. But we can go and have a look at the individual ones just by going back in and evaluating the particular code. So we can go in and just evaluate that particular function. We switch back there. So it's kind of showing you what the view it is it's creating. What does that do? Oh, there we go. Cool. So that's just kind of, I think that's just the geographical data that uses a base for displaying some of the information. And so if we go down through some of the other Oz views, so there's functions that are basically organizing the data, and then there's functions that are viewing that data as well. So here we've got, and there's some code that's commented out as well, so it gives you a chance to go and explore with the data a bit more. This is just some configuration for Oz itself. Where's the interesting views? Let's see, what does that do? So look at the view. So we can see here is just a simple view of just specifically Germany, all the different regions in there, and the cases that are reported in a nice simple visualization. So you can see it's just basically putting in data, which is the Germany name, and it's getting values from this function, which is Deutschland GeoJSON with data, which is probably somewhere up here somewhere. And so you can kind of look through the different views. So we've got another view here, which is bar chart view. Boop. And so this is confirmed cases in China and Germany. And yeah. Boop. And again, you can see, if you look at the data section of this view, you can see where it's pulling this data from. And in this case, it's got an expression that we're actually using to pull that data from. So you can either include a function in here, or you can just put in an expression to do the same thing. And oh yeah, there's one for Europe. Oops. Oh, I'm clicking the wrong thing. Oops. There we go. There we go. That didn't do anything. Oh, that was one I already did, was it? Oh yeah, so that's for European countries. So it's another bar chart for European countries. Boom, boom, boom. Again, so it gives you a nice kind of nice visualizations. You can see what kind of visualizations you can create, or some of the examples. I think there's a lot more examples on the Oz website itself. Okay. So let's have a look at this other one. There we go. And so you can get, so this is again another geographical view of that data, and you can see as you're hovering over the regions, it's showing you the kind of details that we've put into that view as well. So you can get some quite nice, really professional looking visualizations from Oz. It's a really good library. And again, my thanks to everybody who's contributed to that. Is there any other ones? I think that's... there we go. Rate of increased infections. Let's have a look at this one. This is the final one we'll look at. There we go. Oops. Boom. Oh. Yeah, so you can see this is a map over Europe. And again, the visualizations are only going to be ever as good as the actual data that's recorded, and also how well you actually understand that data and can make sense of it as well. But once you've done that, then it's really easy relatively easy to make some really nice visualizations from that. It does seem like there's a lot of code in here, but most of it is actually just configuration. It's just, Oz stuff is just a kind of a map with a title, data, and some encoding. So it's fairly simple kind of to create a view. The challenging bit is to create the right kind of data to make the view work, to fit the view. And but once you've done that, then, which you need to do anyway for whatever library you're going to use, then it seems to be relatively straightforward. So it's something I'm going to try and practice myself with. So I'll put a link to the Clojure Oz thing as well. So Clojure and Oz. If you just search for that, it's probably the first one there is. Yeah. So there's a lot of information about how to actually do this here as well, and some nice videos about what's actually possible in there as well. I think that was done a while ago, but it does give you a good overview about what's possible. And you can also feed these things into things like use Next Journal, which is a very nice notebook written in Clojure as well. But you can also use Clojure, and you can use other languages to drive your notebooks. So that's also a really nice environment to data science in as well. Okay, I'm going to leave it there. We're on 11. I did see, I'll answer that unrelated question in a moment. But again, thanks very much for listening to me. If you need to see any of the other videos that we've got, then they're all on the Practicalli website, and along with my books and contact details. So thanks very much for joining me. So I got a question saying, what is the operating system that has colors versus at the bottom? Oh, switch between projects. Oh yeah, so I'm using Ubuntu Linux, actually the server version, because I've got a RAIDed disk drive, 2 SSDs in RAID, just to make it go faster. And I'm using, instead of GNOME desktop, I'm using Regolith Linux. Regolith Linux. So this is my desktop, and it's a tile desktop, and it's a little bit lighter than that. It's very keyboard driven, and I've just created my own light theme for that. This is based off the Ubuntu theme that you can get with it. And you can either install this as a distribution, or you can install this as a PPA, like private package archive on top of Ubuntu. So I just installed Ubuntu and then just added the Regolith packages on top, and just selected that when I log in. And this is just the standard Regolith switcher. I've just changed the icons as part of the theme. In fact, I think if we go to I wonder where I put that. I did put that there. Nope. If I go to GitHub, actually, Practicalli. Oh yeah, there we go. So I did. So I created my own theme for it as well, because I wanted a light theme for when I was broadcasting. So yeah, and it uses a mixture of GNOME themes for the GNOME applications, and the regular theme for the things that you can see that, oh, that was the previous one I was doing. So I've changed some of the icons down the bottom there as well. Hopefully that answers your question. Again, thank you very much for joining me, and I shall see you next week when we do some more stuff. If you've got any other ideas, suggestions you'd like me to cover, then please let me know, and I'll do my best to present them. Thank you. See, and oh, don't forget to join the Data Science Hackathon this afternoon if you're able to. It's 2 p.m. UTC, and see you there. Bye bye. Where's the end stream? Boom, boom.